I'm Leonardo Nicastro and welcome to Funculus. Today, I'm going to teach you how to do partial fraction decomposition. So we'll start off with an example. The integral of 3x plus 11 over x squared minus x minus 6. So, since the numerator in this rational function is 1 degree less than the denominator, and it cannot be converted into a natural log in this form, then it must be partial fraction decomposition. So the denominator can be factored into x minus 3 and x plus 2. So once you get those values, you then set a to be over x minus 3 and b to be over x plus 2. Or you could switch it around, it doesn't matter. And then you set those two equal to 3x plus 11 over x squared minus x minus 6, which is really x minus 3 times x plus 2. So then once you get there, you have to multiply by x plus 2 times x minus 3. You multiply by those two factors to cancel out on both sides. And once you multiply, you get 8a times x plus 2 plus b times x minus 3 equals 3x plus 11. So, you have an equation now, easy to solve. It's just since a is multiplied by x plus 2 and you need to solve for b, you make let x equals negative 2. So when you let x equals negative 2, you get 0, since it cancels out. Negative 2 plus 2 is 0, 0 times a is 0, plus negative 5b equals negative 6 plus 11, since when you plug in the x values, and when you plug in negative 2 for the x values, you get negative 5b equals negative 6 plus 11. Then you just do the algebra, and you get b equals negative 1. Okay? So, for the next step, since you found b, now you need to find the a. So you got to set, since b is multiplied by x minus 3, to cancel it out, you just set x minus 3 equal to 0, and that obviously equals x equals 3. So then you set let x equals 3. And then once you do that, you get 5 times a plus 0 equals 9 plus 11 when you make the x values equal to 3. And then once you do the algebra, you get a equals 4. So, you found your a and b. Now what do you do now? So then now you still need to integrate. You just made it into an easier form in order to integrate it. So now it will be the integral of 3x plus 11 over x squared minus x minus 6 dx, which was the original equation, will now be the integral of 4 over x minus 3 minus 1 over x plus 2 dx. So now, since you know, it will equal, once you integrate it, it will equal 4 times the natural log of the absolute value of x minus 3 minus the natural log of the absolute value of x plus 2 plus c, because you always got to add the plus c. I have this chart right here, okay? So what we just did was ax plus b, so it'll always be a over ax plus b. That's what we just did, simple. So the next thing is ax plus b to the k power, all in parentheses, to the k power. So it will be the first letter over ax plus b plus the second letter over ax plus b to the second power plus however many powers, which is basically what this represents. It's a to the k terms over ax plus b to the k power, and k is any real number integer. Then the next example is a quadratic, ax squared plus bx plus c. So now it'll be ax plus b over ax squared plus bx plus c. Simple. Then the next one would be similar to this one, the ax plus b to the k power, but it's a quadratic version. It's ax squared plus bx plus c to the k power. So that would basically be the first term ax plus b over ax squared plus bx plus c plus however many terms you keep on going for the k terms. And that's basically it. That was partial fraction decomposition. Thank you.